In this example problem, we're going to go over how to compute a non-ideal pressure in Python. So we know from the ideal gas law that pressure, ideal gas, is going to be the ideal gas constant times temperature divided by a specific volume. Okay, so that is going to be specific volume is normally V, the actual volume divided by the moles, or we can just put it all into this specific volume V. Okay, so I have this correlation. In this case, R is going to be an ideal gas law constant. I'll just put that as liters atmospheres per Kelvin. Okay, so different numbers there just based on the units. And then if we have a non-ideal gas, then let's say we have the Redlich-Kwong equation. Okay, so this is going to be the pressure Redlich-Kwong equation. And so this helps us describe gases where intermolecular interactions are going to be important, or at high pressures, for example. Okay, so I have a different correlation. This just has two additional parameters, and A and B. Okay, so A is going to be equal to 0.427 times R squared, that's the universal gas constant, squared, and then I have a critical temperature to the 2.5 power, and then I divide that by the critical pressure. Okay, so I also have B as well, and that is going to be 0.0866 times the universal gas constant times the critical pressure, or critical temperature, divided by the critical pressure. Okay, so these constants are just going to be used here and there. Okay, so very similar to the ideal gas law, but just a little bit more complicated. So what we want to do now is just go into Python and create a new script that's going to be able to calculate the pressure at, let's do a temperature of, let's do 500 Kelvin, and then a specific volume. We'll say that's going to be 5 liters per mole. Okay, so and then also for this particular gas, okay, so we can look this up in a table. Critical pressure for this gas is going to be 37.2 atmospheres, and a critical temperature is going to be 132.5 Kelvin. Okay, so we have all of our data that we need. We're just going to compute these two in Python now. Okay, so let me go ahead and move this over here. Okay, I'll make it just a little bit smaller so we can still see that. Okay, so we can either use the IPython notebook. So if we go to the start, if we select IPython notebook, we can do it there. Or if you just want to start with use a script file. Okay, so I like to use, for example, Notepad++, and this one will also allow you to write Python scripts. Okay, so I'm just going to come into Notepad. I'll go ahead and save it. Let me go ahead and just save it as on my desktop, and I'll just save it as gases.py. Okay, so you have to have the py file to have it recognize it as a Python file. Okay, so now let's just go ahead and start defining some of these constants. Okay, so my R value is 0.0821, and then I'm going to put a comment here, liters atmosphere per Kelvin. Okay, there's an autocomplete. Okay, so let me go ahead and do my temperature as well. So that's going to be 500, and these comments are just optional. If you put the hash sign, again, autocomplete. Okay, and I don't want that autocomplete on. Okay, so the volume is going to be 5, and that is going to be liters per mole. Okay, and then a critical pressure is 37.2, and that will be atmospheres. Okay, and the critical temperature is 132.5. So for different gases, you're going to have different values there for the critical temperature or critical pressure. But the two things that won't change are these formulas, A and B 0.427 times. Now I've got to do the power of R, and then I put comma 2. So that's how I do R squared. And then times power of TC, and I'll do to the 2.5 power. Okay, and then I'll divide by my critical pressure. Okay, now the value of B is just going to type in those constants there, times R times TC divided by PC. Okay, so I've computed these derived constants, okay, right here, and I've also input a number of just constant values. Okay, now one thing to pay attention to is just the units. Okay, so right now I'm just going to compute the values, compute in atmospheres. Okay, and then let me go ahead and just do the ideal gas. Okay, that's going to be R times T divided by V. Again, autocomplete. Okay, don't want that. And then Redlich-Kwong as well. Okay, a little bit more sophisticated equation here, and that's just going to be V minus B, and then I have minus A divided by, and I'm going to put that in parentheses here, and V, don't forget the multiplication sign, even though I left it out in the math there on the right. Okay, and then times, I'll do power again, and this is going to be T to the 0.5. Okay, so I have my two values in atmospheres. Okay, and then I'll convert to pascals. Okay, to SI units. So I can just take those same values and then multiply by the conversion factor. Okay, so there's 101,325 pascals per atmosphere, and I'll do the same thing for the Redlich-Kwong equation. Okay, so I've got them converted. Now what I want to do is just print out a nice thing to the screen. I'll do this in parentheses so it's compatible with the later Python versions as well. Okay, so I'll just say the ideal gas pressure. Okay, and then I'll put a plus sign just to combine these two. Now if I'm going to combine a number with a string, I've got to convert the number to a string before I display it. Okay, so I'm going to put the str, that's going to convert this number, the PIG, into a string. And then I'll put one other thing for the final. I'll put that in pascals. Okay, so just to display it in the units there. Okay, and then I'll just go ahead and copy this line. And I'll do the Redlich-Kwong pressure, okay, and I'll just change that to RK, and that will also be in pascals. Okay, so I've got it saved. I probably could figure out how to run this in Notepad. I haven't yet, so I'm just going to go ahead and close it. I like editing it in there, but to run it, I'm just going to right-click and edit with IDLE. Okay, so that's going to bring up an editor, and then I can just select from here. I can select F5 to run it. Okay, so there are there's my ideal gas pressure, and then also my Redlich-Kwong pressure. Okay, so let's just review what we did then. If we come back to OneNote, okay, so here are the formulas that we wanted to test out. We had the ideal gas pressure, so it doesn't assume any interaction between molecules, and this one helps out if you're at high pressures. It will be able to better approximate some of these interactions between molecules as you compress them more and more. Okay, so but this one has a little bit more complicated expressions here. You have some derived constants A and B that are dependent on these critical temperature, critical pressure values, and for individual gases these are going to be different. Okay, these are going to be different values that you have to look up. But then I just took a temperature and a specific volume and then computed the pressure for this for these values. And if you recall, then this was my Python script that allowed me to compute these two pressures and display the values.